Welcome to 5G Technology World. I'm site editor Martin Moreau. Analog Devices has long been making components for cellular radios, going back to the days of analog in 1G. With 5G, the company has become involved in open radio access networks, even going so far as to join the O-RAN Alliance. Now, we tend to think of Open RAN as something that happens on the network side of cellular, of 5G, not so much on the radio side. And yet the company has been very heavily involved in Open RAN. So to find out why and how the company is involved, we spoke with Nitin Sharma. Nitin, thank you for being with us today. Now, I normally think of open radio access networks as a software thing, a networking thing. What is Analog Devices doing as far as the open network, the open radio network? How is Analog Devices involved?
Yeah, Martin, it's a good question. I think the reason there's this association rather with virtualization and software around O-RAN is because, the tendency to think about the network is if it gets virtualized, you've got a lot of software running on it, which is true. But I think what's also important to think about is, the only part of the network that really can't be virtualized is the radio. And a lot of the aspects, that an operator thinks about, there are key concerns around spectral efficiency, around operational costs, total cost of ownership, installations, has a lot to do with the radio itself. Our belief is as you go to these open network type of ecosystems and interfaces, that openness actually brings with it a lot of innovation. That innovation, I think, drives the ecosystem in a way that we think is beneficial for the operators and for other players in the ecosystem itself as well.
How does Analog Devices view 5G radios given the push to Open RAN?
Yeah, so I think the way to think about this is, so Analog's been in the business for the radio business since 1G, right? And when you look at it over the years, the entire radio and the processing within the radio has been able to kind of scale to the number of channels, to the number of bandwidths, to the power consumption needs. And especially when you look at it in 5G, there's this disruptive growth in the number of elements, in the number of bandwidths, in the number of frequency variants. And so from an ADI perspective, we've kind of been looking at it not from a component perspective, but rather more from a platform perspective. How do we develop platforms and how do we enable an ecosystem where that platform can be reused in an open way and in a way such that software and algorithms can bring benefit to end applications. And so we've been investing, heavily in radio technologies. It's interesting when you open one of these boxes, the radio is basically condensed down to a few chips. There isn't a whole lot. And when you look at it from a O-RAN perspective, if I use the O-RAN terminology, right, the network components are essentially now split into an ORU, an ODU, and a CU, right? So we play primarily on the ORU space. That's where our interest is. That's where we feel that the innovation that we bring and the openness of the ecosystem can kind of unlock a whole host of innovation. And that's primarily based on some of the platforms that we've been developing over time, like our radio RF transceiver software-defined radio platforms. and then a host of solutions that go around it that kind of enable that entire ORU. So our view into ORAN is more about how do we enable the entire ORU space versus just how do we enable certain components within the ORU itself.
What do you think Open RAN through the ORAN Alliance will bring to radio access networks so crucial to 5G?
Well, so I think what happens is once those interfaces, so if you think about it from the traditional ecosystem, right? For you to do something, you have to kind of do everything, right? Because the whole thing is locked up. We believe when the pieces of the ecosystem are disaggregated and those interfaces are opened, that allows more innovation to enter the ecosystem. And if you look at ORAN specifically, with the split that's happening between the ORU and the ODU, and the fact that that split enables many more players to actually be involved in the ecosystem, some of them being niche and some of them that actually bring to market technologies that may have not been able to come to market in traditional ways. We believe that in itself creates like this robust ecosystem that helps the entire infrastructure market.
What kind of innovation do you expect to come as a result of open radio access networks?
Yeah, I think we're going to see, more vendors emerge. I think those vendors, some of them, that supply chain and that ecosystem, will have more niche applications and algorithms, as an example, maybe machine learning, AI. Those things will emerge, and there will be expertise from different parts of the ecosystem that will help improve the quality of the network. I think also what will happen is, from an operator perspective, they'll have a lot more choices, right? And when you have a lot more choices, there could be choices in terms of innovation, but there could also be choices in how quickly they can roll out a specific feature because of a broader and more robust ecosystem that they'll have in front of them.
Engineers who might be connecting devices to the 5G network, say routers or IoT, will they have to understand the Open RAN concept, or is that transparent to them being a network-only issue?
Yeah, it's a good question. I think it does. I mean, fundamentally, what you're talking about are interfaces that are open and standardized. Like I said earlier, I think as an ecosystem of expertise emerges on how to leverage those interfaces, we will see that someone that's developing a product can leverage that openness in the network. I think that's fundamentally why openness is a concept that's so powerful for the ecosystem.
Do you expect the Open Radio Unit, or ORU, to be more virtualized with Open RAN than it is today?
Yeah, I think so I can speak to the ORU side of things, right? Okay. I think there's a lot of debate, I suppose, on the ODU and the CU side of how much of that get virtualized and how much of that's running on servers and software. I think on the ORU side, what's interesting is that we believe will still stay very hardware centric. Because if you look at it, what's inside an ORU, there's a whole lot of RF, technology, and some level of of digital that actually makes the interfaces out to the DU and out to the rest of the network itself. So I think within that box itself, we see that there's, like I mentioned earlier, there isn't a whole lot of virtualization, right? There isn't a whole lot of things that are running in the cloud. It's radio hardware, radio algorithms, radio software, and then sort of the conversion of that to an interface that connects up to a DU that may be running on the cloud.
What is the role of eCPRI, the Enhanced Common Radio Interface?
It's so on the split. If you look at on the ORAN side, the splits that have been talked about, and there are many that have been talked about. The 7.2, which is the one that seems to have been decided upon, that's an eCPRI interface.
Is the radio in Open RAN any different than in a closed proprietary baseband unit?
So the radio itself, is agnostic. The radio piece of it, we can talk about how the radio interfaces to the DU, right? That piece has a bit of a flux, right? And as the 7.2 gets finalized, but the radio itself is no different in ORAN for an ORAN deployment as it is for a non-ORAN deployment in 5G or 4G. In fact, the way we've actually approached radio design, any of our radios today, they're platforms, right? They're not components, they're platforms. And those radios support 2G, 3G, 4G, and 5G, right? So the radio portion of it is agnostic. The piece that ORAN brings is how do you take that radio interface and bolt on the right lower L1 functions to make it interface and interoperate with a DU in an ORAN system.
You mentioned the 7.2 split. Can you explain it?
Yeah, it's the easiest way to think about that is it's a certain partitioning of the signal processing that you split in a way such that some of it resides in the radio unit and some of it resides in the DU unit. And there are many considerations that go into it, like what is the how much data, how much bandwidth throughput do you really want across that interface. So the split 7.2 essentially defines what type of lower 5 functions reside within the radio unit itself and what then gets moved to the DU.
What are the considerations in deciding on the split between the RU and the DU?
Yeah, I mean, this is the work of the ORAN Alliance and all the different work groups that are, looking at these partitioning decisions, and there have been many of these splits discussed, right? All the way from split 8 to split 6, and it's all about how much of the functionality wants to sit in the radio unit. What are the trade-offs in terms of that interface bandwidth between the radio unit and the distributed unit? Which functions lend themselves more to being centralized, as in multiple radio units connecting to a distributed unit. So which ones want to be centralized? Which ones actually want to be sitting closer to the edge or in the radio unit itself? Those are the considerations that are taken, and the ORAN Alliance has kind of looked at all these splits, and that the outcome of which has been the 7.2 decision. Now that's not global. If you look at what's happening in China, that's more towards split 8. But outside the rest of the world, it seems to have converged on the 7.2 split.
Which functions might reside in the distribution unit, or DU, as opposed to the radio unit, or RU?
It's things that are closer to the signal processing of the radio itself. Like an example of it would be like FFTs and IFFTs are an example, right? A lot of the carrier-specific functions sit in the radio. There are benefits for them to be sitting in the radio. The eCPRI as well, obviously, right? That sits on both ends of it. Those are kind of examples of what sits in the radio side. There's also versions of the ORU where some level of beamforming sits in the RU side as well.
Which functions besides FFT might reside in the RU radio unit?
Yeah, you could think of certain signal processing, certain partitions benefit from being closer to the antenna. I'll give you an example of this. So we traditionally think of an ORU, and within the ORU, there's a bunch of RF, and there's signal processing done on that RF, and that signal processing actually has implications at the system level. One such example is like digital pre-distortion, right? It's a technique to actually improve the linearization, the efficiency of a PA. Which, by the way, in these massive MIMO systems, there's a big benefit there. Just like how they've been in the macro side, signal processing. And now, in order to do something like that, there's a thing called bandwidth expansion. You actually need to. There's a lot of bandwidth that goes past that interface. If that bandwidth were to be sitting outside the ORU, you would have an expansion in bandwidth that would be very taxing on eCIP3, right? So that's an example of where pulling that function into the RU, which is where it resides now, helps with the interface bandwidth between the RU and the DU. So there's signal processing functions like that tend to want to be local to the radio itself versus being centralized. And those processing functions then sit in the DU, the ones that actually want to be centralized.
Why would some radio functions reside in the distribution unit, or DU?
I think it depends on what is being aggregated. What functions would want to sit in a centralized, where awareness of other RUs perhaps is important.
I see.
Right, and that's the whole reason for having that DU in its the reason for having the DU there in the first place is such that it can be kind of an aggregation node of multiple RUs.
How does Analog Devices participate in the ORAN Alliance?
Yeah, we're actually quite active. We are in work group 1. We participate in work group 4. We have a lead role in work group 7. We're helping, in fact, we're the technical editor for one of the reference designs that's coming out of one of the work groups. So we have high participation in our Alliance.
What can engineers do about the excessive heat produced in 5G base stations?
Yeah, it's a good question. So heat, we usually think it's lower the power consumption of the base station, but what's important is not only to think about to think about how to lower the power consumption, but you almost have to think about thermal density, like spots in a radio that run hotter than other spots. And distributing that out is very important, so you don't end up with hot spots in the radio. Bringing that back to what we talked about earlier, where you choose to do the signal processing can help you with that as well. So as if you can partition a system where you take that heat and distribute it out in a way such that you partition the signal processing that spreads the heat out across the system, that's important. I think algorithms have a very important place to play there as well. We talked about DPD, where having the right amount of DPD and the right efficiency can help a lot reduce the power of the power amplifier, which tends to be one of the larger thermal challenges in these systems, and having the right levels of DPD are important as well. So I think thermal design is important in terms of how you spread the heat, and just generational improvement in terms of how you reduce the power consumption of the radio, the associated signal processing is important as well.
Nitin, thank you for speaking with us today, and we look forward to speaking to you again here on 5G Technology World.